So the last session, I do want to just pick up on two main bits that I did have to cut out of the demo side on the session after lunch. Was it no, before lunch. And that's around the business continuity and disaster recovery options within Azure. Now, obviously, I mentioned earlier around that other cloud provider that shall remain nameless, AWS, that had a lovely outage the other day. Not going to talk so much about intra-cloud or inter-cloud failover dependencies, but more about how you can start to take them steps from your on-premise and either look to reduce your secondary data center footprints or just generally gain levels of protection where you might not have previously had it. Just going to dive into the consoles and talk a bit around some of the options on that, and then we'll move on to how we can start to control more of that all-you-can-eat world. So as you heard Paul say, Paul's a bit of a control freak, your words.
Thanks, Steve.
That's all right. Controlling some of them budgetary constraints, making sure that you know who's commissioning stuff, more importantly, what it's actually costing. And mentioned right at the beginning of the session, introduce that PACE tool set that you can start to use and leverage. So Azure Backup and Site Recovery, two very distinct tool sets that I mentioned earlier. Clues in the name, backup and one's recovery. So Azure Backup can be utilized either as a method to back up resources that are in Azure. So there's not much point saying, fine, I'm going to put 20 servers up in the cloud and then lose some of the benefits that you would have on premise in terms of backing them up as full bare metal state machines. So we don't want to go down the route of having to say, fine, we'll put an agent on it and just back up the files. We want to be able to do that quick recovery, but on a virtual machine level. So they introduced this service called Azure Backup, where you can point it at a VM, and it will do that under the covers, backing up at the infrastructure layer, and give you an entire image that you can just replace back if something does go wrong. Now they have just lit up another feature as well, where we can now basically mount a backup image in Azure and do item level recovery as well. And that's only just been announced within this last month. On the flip side, if you are working in that hybrid model and you have on-premise components, you could absolutely carry on using your on-premise backup software, so your Veeams and your Commvaults of the world, and protect up within the guest VM or at the actual VM level, and use agents up in your Azure VMs to back up things like SQL databases that are running in IaaS. However, again, that would be a bit, what's the word I'm looking for? Not backwards. It would be a bit of a drain on resources if you're dragging them all back to on-premise.
Inefficient.
Inefficient, that's the word. The other flip side is tapes. I make no bones about it. I hate tapes with a passion. And that's because I come from a background where I was responsible for the infrastructure teams that were backing up to tape. I mean, this is 5-6 years ago since I left that environment. But I was the one that then had to sit down there and calculate how many more tapes do we need for the next 3 months, 6 months? How much is it going to cost? How much data are we pushing to it? And that alone, trying to work out the complexities in Excel was a nightmare, let alone then seeing the bill and going, how much are we spending? So as more and more organizations actually need to spend time, or not spend time, actually have to retain data for longer periods, it becomes even more incentivized to find a better way of doing it. I just realized I left the share over there. So within the Azure portal, you'll have this lovely little node called Recovery Services Vault. See if I can do this without even looking. Awesome. So there is this little thing that I've commissioned. So this is our Recovery Services Vault. So very easy to understand service. A lot of it is common sense labeling. So we have the option to back something up or replicate. Now, if I go to the backup tab, you'll see immediately it's giving us this hybrid choice of where do you want to back something up from. Let's zoom in a bit. So what is my backup goal? Where is your workload running? So dead simple. Is it in Azure or is it on-premise? So if I have something in Azure, what's it going to be? Well, it's going to be a virtual machine. It's the only option. what's my policy? So when do I want to back it up? How long am I going to retain it? So I've created my policy. So it should just, if the internet ever decides to keep up with me today. Come on, there's my default policy. So I'm backing up daily at 8 o'clock and I'm retaining it for 30 days. A little bit aggressive. And then there's my list of PCs that I can back up. So within this subscription, just choose the VM I want to back up, and I'm not going to click OK because I don't want to back that VM up because it's a test, but that's as difficult as doing your backups in the cloud gets. Now, if you are running stuff on-premises, so log on to my DPM server. So while I'm using DPM from the System Center suite, there is, as part of this subscription service in the cloud, a component that you can download for on-premise, and rather confusingly, it's called Azure Backup. So the service is called Azure Backup, and the software is called Azure Backup. Go figure. All it is a cut-down version of the DPM product. So when I say cut down, all the features are there, apart from tape backup. Because it would be rather counterintuitive to say, here's a cloud-based backup solution that you can then back up to tape. So it's designed purely for making sure that you have this online bit, you don't have that option. So anything I show you in here, just ignore that option. That's the only difference. So these are my SQL databases I'm backing up on premise. So we're going to item level recovery now. So I've got numerous different clusters in there, numerous different databases that I'm protecting. If I want to extend this protection, all I do is add online protection. So I've registered my DPM server to my Vault. That's the only bit that I'm not showing you at the minute, which is basically download a Vault credential from your Azure subscription, add it to the console, and then it becomes a simple case of what do I want to back up? Maybe I don't want to back up everything. There's my operations manager database. When do I want to back it up? Let's back it up every day at 9 o'clock. How long do I want to retain it for? Don't really need 180 days of retention, so let's keep 30 days worth of retention. Actually, no, let's keep 5 days worth of retention. Let's keep 52 weeks, 12 months, and 999 years. Now, the retention period in Azure is literally 999 years. If anyone needs longer retention than that, I'm really not that fussed because I'm not going to be around that long, so knock yourselves out with how long you keep it for. Next, and then two choices. Automatically over the network, that's more of that business as usual activity. You're just adding some individual databases, some VMs up into the cloud for storage. If you want to do a big bang approach, you can. You basically plug some disks into your servers. This will prepare a big file. You ship them disks off to Microsoft, and Microsoft will load it into the data center. So you don't have to sit there and think, fine, we've got 22 petabytes on premise. That's going to take the next 220 years to replicate up on our 2 meg link. Find a 220 petabyte USB disk. Find some sort of storage that would actually take that amount, ship it to Microsoft, and they will load the data for you on their big backbone. Does that make sense in terms of starting to protect some workloads? Not exactly the most complex of demos because it is a fairly simplistic methodology of doing it.
So just give us an idea about what technology Azure Backup is using. You said it's DPM. What version of?
Yeah, so it's Azure Backup or DPM on-premise, and obviously on the cloud-based service, that's the magic sauce that you don't really see the stuff under the covers. Now, recommendation is to move to DPM 2016 or the latest version of Azure Backup, mainly because as Microsoft have just refreshed the product sets, they've introduced one significant feature, and that's they've fixed the underlying storage mechanism for the backup product. Anybody in here have the joys of DPM 2012 or below? No? Awesome. You haven't suffered pain. So the new version of it is utilizing some of the Windows Server 2016 features. So you'll notice that I am on a Server 2016 server. And that's because it's specifically utilizing now storage spaces to aggregate disks into a centralized pool to make it easier to expand it, and then it's using the new REFS file system to actually provide some extra features. So it provides storage space improvements. So the storage size has dropped in the latest versions of Azure Backup for on-premise retention by about 30 to 40% compared to the previous products. And speed. Because of the REFS technology, it's now using block level cloning to be able to take the chunks and the replication and merging them changes back in. So this is all block level backup. So when I go and back up that SQL database, it doesn't take the entire 200 gig data warehouse down the line. It takes the changes from that day. So it's doing all the change tracking, transfers the blocks, and then merges them into that central set. The other side of that is when it pushes it out to Azure, it's doing compression on the wire up into Azure. So you're not transferring 200 gig if that's what your data set changes. You'll be transferring a subset of that. When it gets to Azure, again, that's starting to do some lovely dedupe and compression on the data store. So when you are storing it in Azure, you don't, if it is a 200 gig database, yes, you'll pay for that initial 200 gig minus a little amount, and then each subsequent data load of your churns are then compressed, compared against other data sources, so you're not always paying that top level amount. We always recommend doing your storage pricing based on no compression or a certain factor and a low factor. So Microsoft will say their compression ratio can get up to about 70-odd%. Don't do your pricing on 70-odd%, do your pricing on 20-30% compression, and then just be really pleased when your bill's even lower. Make sense?
What is the backup software product that Microsoft is using? I think they're pretty bad something to talk to the end.
What, in the cloud or on premise? No, on premise it's basically Data Protection Manager. So they've had that around since the 2008 version. So it's gone 2008, 2010, 2012, 2012 R2, 2016. So we're 5 generations in. So it's quite mature now. And strangely enough, even though some people get put off by the whole MMC console for the on-premise bit, it does what it says on the tin. It backs stuff up, and it backs it up successfully. More importantly, and this is what I'll always say about any backup or any protection product, it's not about how it backs it up, it's about how it restores that data. And this is where DPM consistently will give you your data back. And when you're using the cloud-based extension, so the Azure Backup, if you lost your on-premise infrastructure, as long as you have that initial encryption key, because it's all encrypted in the cloud, you lose that key, and this is the one time I tell people to write that key down on a piece of paper and go and stick it in the safe. Don't ever lose that, because if you lose it, you do not get your data back. If you have that key, you lose your data center, I can go and spin up a VM on my laptop, connected to the internet, put that encryption key back in, join it back to the vault, and start pulling data back down from the cloud. So it's very easy to recover that data.
Two important points there, right? With the key, the encryption key, you generate that. So Microsoft can't see your data, it's encrypted with that key. Right? There's that security and compliance for your backups, one. Two, something to just reiterate is, the naming is a bit odd, but Azure Backup, right, you can actually just install just the agent on-prem servers. You don't even need a network connection as long as that server can connect out. If you've got 10 or 20 servers, you don't want 10 or 20 servers all going up to Azure. It's inefficient, right? So that's that backup server that you would have on-prem. Those 20, 30, 40, 50 servers would come onto this guy who would dedupe, compress, right, and upload. And you can have a staging area with USB disks, if you like, right, on there. So that backup, the DPM 2016, is a major advancement. And when we're thinking about architecturally, if we're saying, okay, we're trying to simplify environment, etc., it's worth having a look at, especially if you've got those licenses, those type of DPM things in your enterprise agreements. You're paying for some of this stuff.
Yeah, one thing I will say again on the DPM side is talking about that, using it as that centralized vault to bring the data into before uploading it to the cloud. When you do start to look at the cloud as your long-term retention period, you start to consider radically reducing the amount of data you store on-premise on disk. At the end of the day, most backups will be targeted at, I've deleted that, I deleted it an hour ago, I want it backing up from an hour ago, or restoring from an hour ago, sorry. So why bother storing 30 days worth of data on-premise on disk when the vast majority of restores are done within the last day or two in terms of data? You can still, from this console, so if I go to recovery, I just remembered in this test environment I don't actually have anything up in the cloud. That's a good start. But it would be the same principle that if I did say, well fine, I do want to recover that database, when do I want to recover it from? 4 days ago. When you go to do the recovery and you pull it from from the cloud, it's seamless. All you do is choose your time period. So it could be going back years, months, days. It will show that it's not recovering it from disk, so it's past the 5 days. And it then will pull it down from the cloud. So it might take a little bit longer depending on your internet connection, but it will generally still be quicker than either having to go and find the tape, manually put it in, get the index catalog, get the tapes pulled to restore a file. So it's seamless in terms of the recovery side. It's just a slower disk tier as such. Does that bit make sense? So reduce your on-prem footprint, reduce your data storage, and utilize what Microsoft's giving you in terms of cheap storage up in Azure.
Yeah, and just because you've got servers in Azure doesn't mean you don't back them up, right?
Yeah.
There's still servers, there's still, if you've built infrastructure, you know, what have you got? Certain services you might not need to worry too much about, like some of the technologies, things like ADFS, for example. You can create farms. If you're intelligent, you'll create maybe 1 or 2 ADFS servers in UK. You might stick another 1 or 2 over there in Western Europe, etc. Right? Those type of technologies where they're replicating their data, you may not need to worry too much about server level backups. Right?
Or you might back up one,
yeah,
because it's easier and quicker just to spin up a new VM from a template. You've saved that template from when you did it first time, spin it up, add the ADFS feature, and it just joins the farm and replicates. No point backing it up. I'm not paying for something that will take me 5 minutes to restore from scratch.
But we have come across customers who said, now that I move all my servers into Azure, it's Microsoft's problem, I don't have to do backups.
The cloud is not some fluffy unicorn place where everything magically happens and you don't have to worry about anything evermore. Difference on SaaS services was the provider is doing that responsibility. Anything infrastructure as a service still needs to be watered, fed, patched, backup, managed, monitored, maintained, which is why that's a starting point, not an end point, because you want to start to reduce that level of complexity, all them tasks, by moving to PaaS and SaaS where possible. But while it is IaaS, same normal rules apply. Carry on doing your normal traditional backup tasks. Azure Site Recovery. So this again, still in that ASR vault, so alongside the backups, but I've just gone down to Site Recovery. Just a quick idea. These are the different infrastructure moving components. You notice that I have splits between, if I'm using System Center Virtual Machine Manager, might as well integrate with it. So I already got a load of config there. I can just take control of it, see the cloud, see the methodologies I'm using. There's all my logical networks that I'm using. So I will do that way. Why is my screen flashing? Network mappings and so on there. You've got VMware and physical devices in there. So this is using what we call the Unified Recovery Server. So as I mentioned earlier, if you treat a AWS VM as a physical box, then it basically gets an agent on it, it talks to the Unified Recovery Server, and it will replicate across and into Azure. And then you have Hyper-V servers where you don't even need VMM, it basically uses the replication technology built into it, and it will replicate it up into Azure. The other flip side is, when we talk about replication, if you do have multiple on-premise data centers, you can use this as a top-level service to actually replicate from on-premise data center to on-premise data center. Use this as a management and orchestration engine, because when I get to another bit in a minute, it's about recovery plans. You're using your data center, but in an intelligent manner. Let me go across that to recovery plans.
So it's just out of curiosity, are you guys familiar with ASR, Azure Site Recovery? Understand the concepts behind it?
Yeah.
It's pretty much DR in the cloud kind of concept, where the control mechanism is managed at the Azure layer, and your recovery sites, as Steve was just saying, could be on-prem to on-prem, VMware to Azure, Hyper-V or physical to Azure, right? So data center 1 to data center 2. If you're thinking of your traditional methods of disaster recovery, you would say, okay, we've got a site down. I want to spin down the web servers first. After they've spun down, I want you to shut down the database nicely. Then I want you to shut down that database. Then I want you to bring that up on this site in the reverse order, right? And I want you to get on there and check the website that everything's up and running. So that's a controlled, and then you've got your uncontrolled, where that's gone down, follow that. So this is controlling, or you're managing that design with this, okay?
Yeah. So that's the fundamental concept behind Azure Site Recovery, is we are doing the block level replication of a VM to an endpoint. Not interested whether that endpoint is on-premise or in the cloud. On-premise, major benefit on that one is if you had the traditional type of dual EMC storage and you didn't want to pay the extortionate amount for the replication licenses at the hardware layer, then start to do it in the software layer. It's there, the capabilities are present within Hyper-V. There is some integration if you got some of the VMware stuff. There's ways to do it at a software layer rather than just relying on the hardware vendors' licenses. Doing it up into Azure, it will replicate it, it will create that VHD blob, it will know what the sizing of the machines need to be, and you can define what network segments that they will come up live on. After that, you have this plan approach. So my plan's actually broken because where it says 2 machines, I took my test machines out of it and didn't edit my plan, which is always fun. But this allows me to start to define out what's going to happen in my process. So starting to take the approach of, well, fine, rather than just saying we've got a load of stuff backed up and we've got stuff replicated, but when something does go wrong, you're either running around trying to find the relevant people at the right time, saying, how do I recover that? What order do I bring it up? Do I need to do this first? Do I need to do that first? It's about, again, taking it back to that planning and that architectural layer, plan out what your DR should look like, and then define it in a plan. And says, well, fine, I must make sure that, as Ken just said, everything's shut down. All these things must be shut down before we invoke an actual failover. Obviously, if it's a non-graceful failover, there's differences in that. But if we have partial loss of service or we just want to do a planned failover, let's do this gracefully. Let's shut them down, replicate the last blob so we have a shutdown consistent crash, or a shutdown consistent failover rather than an application consistent failover. Then what do I want to do? Well, I want to make sure that this group of servers comes up first. Let's get any domain controllers up and online. Chances are you'll probably be running domain controllers permanently in Azure, so you won't have to consider that. But let's bring the SQL servers up first. Let's get the database platform up, ready for servicing requests. Maybe I want to run a script, so I can add an extra step and say, well, fine, before that, let's add a post action to that group. And then it can either be a manual action, so I'm going to go and make sure I shout at Ken, say, Ken, cans are relentless, I'm going to be at this a while. Or a script where we can hook into Azure Automation, so we can have some predefined scripts ready that do things like flush the IP caches, or DNS caches, because we're going to be injecting IPs on failover. It's a different network segment. Maybe we want to make sure that we do pings and make sure that servers are up, make sure that services have started. Whatever we want to do, it's all about trying to eliminate the need to do manual tasks. Add that step in. So I want to get rid of that now. Go. Make sure that group of servers comes up, then another group of servers, then another group of servers. So we're defining out the actions to take when we decide to do a failover. Now, when you have that, you've got these other couple of buttons. So most organizations will almost pay lip service to DR. It'll be a case of, yes, fine, we've got DR, this is our documented process. How often do you actually invoke and test that? Do you actively fail over? Do you test the failover? Do you run services in another location? Very hard to do in most organisations unless you have all of that replication stuff set up on premise with expensive licenses and technologies that can handle bringing it across. This is bringing that type of thing in. The other flip side is you'll get organisations say, oh, we have a contract with an outside supplier. If we have a big disaster, they'll rock up with a great big bus, a lot of hardware in it. It's usually a horse box for some reason. A load of random hardware in it, and we hope that we can go and find the tapes and start restoring services too. And then them organisations will, yes, find part of the contract, they will turn up every 12 months and we will do a DR test, which usually consists of a day finding the tapes, another day trying to make the tape loader actually connect to the random piece of hardware and installing ESX on it, and then another day of saying, I've had enough of this, it's too cold, sit outside of here. This allows you to basically go test failover whenever you want. So the test failover, not that I've got any plans or replication, would take the last replicated set, so it's a crash consistent failover, and then it will bring them up in an isolated VNet within Azure. So great, straight away I can say, did it work? Did it bring it up in the right orders? Yeah, awesome. It also has an unintended side effect that when you say, well fine, we've got a service pack to put onto Aggresso or something, don't really want to do that in live, it's winging it a bit too much even for me. Don't want to have the expense of having a replica on-premise environment that we're running all the time, and it takes far too long to make it worthwhile for testing a service pack to replicate it and copy them VHDs into an on-premise environment. If you're doing site recovery of it, do a test failover. It's isolated, but nothing to stop you going and applying that service pack to that environment. Test it out. Does it work? Yeah. Do some user acceptance testing. Yeah, pretty happy with that. Trash down your test environment, go do it in live. So you can wrap it up as part of your change control processes. Now, don't get me wrong, there's costs involved in that. While you're using just the service for replicating, you're only paying a service charge per node and the storage you're using, so it's fairly low. When you spin up a VM, so when you do a failover, you are charged for the compute for the VMs that you're running. So it's not as if you're paying for 24/7 VMs, you're paying for the 1 or 2 hours that you're doing some testing. So it's still minimal costs.
So that's very strategically really important. Where I come from, I don't know about you guys, but we had a massive dev, test, pre-prod and prod environments. So we had 4 environments. And one of the biggest bane was that our pre-production environment was not very accurate to our production environment. So we'd all have our developers in their dev environment, right? Write up a bit of code, stick it into pre-prod, it looks fantastic, get pushed out into live, crash. And
it's just bad code, that though.
So
problem in developer chair.
This is a very, very powerful tool to see beyond that, that gives you the ability to have a disposable pre-production environment in your pocket that's less than an hour old, right? You need to put a service pack on your Exchange server, right? You need to do something to your SharePoint farm, right? If you've got the DR plans and all that, you spin it up in test without impacting live, go crazy, and then finish up, throw it away at the end of the afternoon. Do that to an individual developer if you want.
Yeah.
Very powerful.
On the flip side of that, obviously, you can do test failovers whenever you like with zero impact. Planned failovers, again, that thing that was really difficult to do. This will do planned, as in the name. This is where you make sure you communicate to the business there will be an outage, but this will shut down the VMs gracefully on site, finish off all the replication, and then bring it across into a production VNet. So one that is connected back to your on-premise, so you can run it across there for a set amount of time to prove that if we did fail over, this is exactly how it would run.
What sort of realistic outage are we talking of here? Because in many respects, I sympathise with everything you're saying about that move from when we used to have a provider like SunGuard turning up with a lorry that you realise you never put the plug in place that they would have to plug into once you've, and then you move to the kind of NetApp or EMC sort of solution that you move to, and then you realise really it's far too complicated to do these kinds of things.
Yeah.
But bear in mind when this each one of those that have been introduced, they were introduced in a similar way to this. So this is really easy, just do that, whatever else. And how realistic are we talking about this being?
Yeah.
You get where I'm coming from?
Yeah, absolutely get where you're coming from. So
a skeptic rather than a cynic.
Very realistic. So because you have that test failover button, you can test, and test to your heart's content to make sure that all the order, things come up, the re-IP addressed, that it is going to fail across successfully. In terms of the planned failover bit, which is where you will introduce an outage scenario, you will know from, obviously you're not going to do it next day after you replicate something, but over that time period you'll see what your amount of churn is, and this all comes down to the churn. If you're churning through 500 mega minute changes and there is a 5-minute replication, then you're going to have to deal with 2 gig of data per VM or whatever that has to be transferred on a planned failover. So this is where it comes down to it, is that data churn scenario. Spinning up the VMs in Azure, obviously that is just click the button and it does all that side, so it's ready for you. It's the outage period starts from when you click test planned failover, the amount of time that it takes for on-premise VMs to shut down, the data that's churned to be replicated, and then the minute or so that it takes for the VMs to come up online within Azure. So your bandwidth of your network and your churn rate determines your outage period.
So by the time you've made that transition then to full Azure or full cloud or whatever, you're talking of substantially lower churn rates.
Yeah.
So you've got to think a little bit outside the box as well. Like we talked about things like ADFS have got their own replication. Domain controllers have got their own replication. Would you ASR technologies like that?
No.
So you've got to think, what would you really DR? Because a domain controller, right? Domain controller goes down. Well, I could spin up another one as long as not every single domain controller has gone down, right?
But this is where you would run a domain controller for your services that are going into Azure anyway. So you'd have a couple of domain controllers in Azure, so you don't need to bring them up.
Yep.
ADFS.
Stick one there. There's your DR for your domain controllers.
ADFS, your web proxies, you might be running them in Azure already, or you might have one on premise and one in the cloud.
Just
don't bring one across. DR is always about providing a minimum acceptable service level.
Yeah.
So don't say everything, and also take the opportunity to say, well, that SQL server, that's critical. We need to bring that across as DR. Well, don't bring it across with Azure Site Recovery. Look at what you can do with stretched databases, SQL always on, re-architecture wherever possible at the application layer. Because yes, you might say, well, fine, we need to buy a SQL Enterprise license for that. Fine. It's probably cheaper to buy a SQL Enterprise license the once, use SQL always on to have it up running in a VM in Azure, than replicating and the time and the outage it would take. Because when you fail over then the other services, it will swap immediately to the SQL always on that's already there, already ready, no downtime and waiting.
And the best strategy, as Paul was talking about earlier, as we said, is software as a service if you can.
Yeah, sure.
I mean, that is the best strategy. You go back to the vendor or the product guys and go, well, yeah, okay. Oh, Oracle's a great example of this. Larry Emdett stood up, I think it was about 2014 or 2013, he went, cloud flash in the pan kind of thing. Oracle bought about 600 companies a year. 2 years later got up and said, oh yeah, Oracle's now going to be in the cloud, Oracle services and all that. We're still waiting for Fusion. But pretty much everyone's seen the game change in that sense. And you should be saying, well, okay, if I'm using this and I need to upgrade, why am I doing this? Why am I paying you? Why haven't you got this as a service for me?
Yep. Any more questions on ASR before I move on from it? No. I'm sure I've forgotten something I wanted to talk on. It'll come to me randomly later. So the next thing I obviously wanted to move on to is that how we start to manage all this stuff that you start to put in the cloud, or how do you start to baseline how much is it going to cost to run it? So mentioned very briefly earlier, and Ken said I'll demo this, so I might as well bring it up now, and that's the Azure Cost Estimator, or PACE, it's the Power and Azure Cost Estimator. Mentioned earlier, this is a free community tool. We're not going to release it on the TechNet Gallery and stuff though, because we do need to onboard people into the subscription basis and give you some install instructions and maybe some support on it. It's utilizing OMS. So we actually have the OMS agent that we get deployed out into the boxes. That provides CPU, it actually provides some inventory information, so what OS are you running, how many cores, how much memory you got allocated, what your CPU, what your memory utilization is, what your disk IOPS and your network throughput, because then we can actually start to look at it either under a current utilization model, moderately optimized, or highly optimized. So this is taking that idea of if you just lift and shift stuff, that's what you've got allocated, this is how much it's going to run. If we say, well, fine, actually, we can see that you're utilizing only about, well, less than 60%, we can take down a couple of cores and so on, or highly optimized, we'll drop it down to the bare minimum average that we can see you utilizing. So we're not actually doing average, we're doing about the 90th percentile, or I think we even got a bit more nice with it, went 95th percentile. So you can see these servers that are in the service at the minute would be about 178 grand a year in terms of service charges. Not all of them VMs will migrate. So we do put up the flags to say, well, actually, if you have a 32 core VM with 512 gig of RAM, actually, I know nowhere near that in terms of memory and CPU cores on that VM. If we say that, fine, you've actually got some blockers. So you've got a 3 terabyte OS disk, for example, that you cannot use within Azure. No point giving you some pricing around that lot, so we'll tell you that you cannot migrate. Next one is regions. So we are pulling data back from the rate cards. So this is live data. This isn't a case of we've got a little spreadsheet in the background that we have to keep on remembering, oh, Microsoft have updated the VMs and they've increased the price by 50%. We're bringing the data live from Microsoft, which also means we know all the different regions. So we say, well, fine, if we're running it in the UK West, it's 178. If we decided actually we want to run these services out of the East US, the price is significantly different already. This is one thing that I do always like to highlight. The price is not equal across all the regions in Azure. Some of the data centers might have been there longer, they might have different or newer technologies. Always hunt around to see where it is most cost effective. Regulations depending, obviously if we have to deploy it in the UK or Europe, fine, we have to pay a bit more. Surprising that, the US charge less for the services. Could be Windows or Linux VMs. Again, if we want to apply any limits, so we want to see everything that's within the 1 terabyte limit. And then if you do have any sort of EA discounts, you can apply that and say, well, actually, fine, we've done a commit like Paul did, and then Microsoft give a certain discount percentage. So current utilization 131. Let's go for moderately optimized deployment. Unfortunately, the filters don't carry through. So let's go for the East US again. So that was it 134 in East US? It drops it down to 119. So already a bit of optimization's going to save us money. Highly optimized. Again, even in the UK West, it's still cheaper than just doing it normally. But if I put in the East US, we're going to knock it down to 72 grand. So this is that whole idea of just because either fine, we slung it in with 4 cores and 16 gig of RAM because we've got loads of cores on premise and stuff, or the supplier told us it had to be an 8 gig of RAM box. Actually, when you do it based on what it is actually utilizing, so we can drop it down from 131 straight down to 72, so nearly 60 grand saving just because we're not taking it at face value. So it's all about making sure you're right sizing your environments. You can do this across individual VMs, however you want to slice and dice it. Does that make sense in terms of giving you a bit of visibility of what you're using, what you're thinking about migrating. Like I say, this is not doing some of that server dependencies. This is supposed to be a very quick and community tool that you can just go in, use, get a bit of an idea to start thinking of whether it's cost effective. Then you go down the whole, what other things do we need to consider? What are the dependencies? This isn't counting for networking charges, so data flow in and out of Azure. So there's still extra things to consider. It's a baseline starting tool. Yeah? Awesome. So I know that we're coming up on the hour, so I'll probably pretty much flick it to question times. And is there any questions from anyone?
42 is the answer.
Is that your age?
Hitchhiker's Guide.
Take it there's no questions online, Catherine?
Alright. I haven't seen any, no.
No.
Yeah, no.
No questions from anyone? No, awesome. Well, thank you all for attending. It's very much appreciated, and just about everyone managed to last till the end of the day. If there are any questions that you don't want to obviously talk around, or if there's any follow-ups, please do feel free to reach out to either myself or Ken. There's the account management team, Tasha's in the back as well. There is info@poweronplatforms.com. I don't think it's on the last slide, but the main website is. I will always call out, because I love promoting it, that Power BI report side that we use for the Azure cost estimator. One of our guys who's also very active in the community has released a config manager and service manager Power BI dashboard as well. So if you have either of them tool sets, it's on our website, go to news and blogs, and you can find it and download it as well to use in your own environment. Almost able to talk over that. Brilliant. Thank you very much, everyone.